Hello, Assalamualaikum and hi again. In this lecture, we're going to discuss the signal conditioning for strain gauge. Strain gauge is used to measure the deformation happen in the body. When the force is applied onto the body, it will produce stress. Then from the stress, we can calculate the strain. Then relation to the strain and the resistance in material, we can get the change of resistance. Once we get the change of resistance, we need to convert the value to the voltage. So our discussion is here. How to convert change of resistance to voltage. So the answer is using Winton Bridge. So let's see why the Winton Bridge is suitable for the application with strain gauge. So in strain gauge, there are two critical factors that we need to consider. The first one is due to the small changes in resistance, meaning the resistance output from the strain gauge is very small, 0.004 ohm, for example. That is a very small change in resistance. So therefore, we need carefully design so that this small resistance is able to be captured in our converter. The second one is the need to provide some compensation due to the temperature effect. We already know that the properties of the metal, the resistance in the metal will change due to the temperature effect. That is due to the thermal properties in the metal. When the temperature change, the electrical resistance in the metal will also change. So therefore, when we're using strain gauge, the change of resistance will come due to the two types. The first type is due to the strain, and the second type is due to the temperature. Therefore, we don't want the effect from the temperature, that we need to compensate that. By using strain gauge, we will be able to provide solution for the two critical points. As we know that strain gauge is very sensitive in the changes. So we are able to detect any small changes in resistance. For the second one, which is the temperature effect, compensation for the temperature effect, due to the shape of the Winton Bridge, it will be able to provide compensation effect in order to eliminate the temperature effect. So we know that the equation for null, equation for Winton Bridge is this equation. And then if we consider that R1 equal to R2 equal to R3 and equal R4, we'll be able to calculate the voltage output by using the equation of change of R over R divided by 4 plus 2 change of R over R. We'll be able to convert change of resistance to the change of voltage. Let's look how Winton Bridge will be able to give a temperature compensation. So here we have a one-arm bridge. One-arm bridge meaning that there is only one active strain gauge. Even though there is two strain gauge in this diagram, but only one is used to measure strain. The second gauge here is a dummy gauge. The function of dummy gauge is to provide temperature compensation. RA here is our active strain gauge, SR4, and the dummy gauge here is R3. Both strain gauge will have a change of resistance due to the temperature effect, because the temperature environment will affect the change of resistance in the strain gauge. So let's look how the Winton Bridge will be able to compensate the temperature effect. From the null equation, we have R1 over R2 equal to R3 over R4. Both strain gauge R3 and R4 will have change in resistance due to the temperature. So R3 we have change of resistance due to the temperature. R4 we also have change of resistance due to the temperature. As for the change of resistance due to the strain, only R4 will have change of resistance due to the strain, but R3 will not have any change of resistance due to the strain because it is in insensitive axis. So therefore, we'll be able to compensate this value here because both strain gauge change due to the temperature effect. So using the right configuration, meaning R3 must have pair with R4, therefore we'll be able to cancel change of resistance due to the temperature, leaving the equation becoming only R1, R2, which is the constant resistance, R3 and R4 plus change of resistance due to the strain. So therefore, even though there is a change of resistance due to the temperature, but the effect is already cancelled out here. So this is one arm bridge and also how it provides temperature compensation. Then we have half and full bridge. So half bridge meaning there are two active gauge. Two active gauge. Why? For full bridge, there will be 4 active gauge. Active means that the strain gauge is used to measure strain. So if there are 2 active gauge, then there are 2 strain gauge used to measure strain. If 4 active gauge, meaning that all the 4 strain gauge is used to measure strain in the full bridge. For example, in this bending load cell, we can see here there are 2 active strain gauge because these 2 active strain gauge is in the sensitive direction, while the other 2 here is dummy gauge. D represent dummy, A is represent active. So the function of dummy gauge is to provide temperature compensation. So this is the configuration for half bridge. So there are 2 strain gauge and the configuration, it must have pair with one dummy at its side. So A1 will pair with B1. B1 is the dummy, A1 is the active, and A2 will pair with B2 because B2 will provide temperature compensation for A2 and B1 will provide temperature compensation for A1. Next is bridge constant. Bridge constant is a relationship between A is the bridge actual output and B is the output for one strain gauge only. The value that we want is the bridge actual output. So bridge actual output is equal to K multiplied with B. So K is the bridge constant. It will depend on the type of Winton bridge configuration. And B is the output if only one strain gauge is used. So the bridge constant for one arm bridge is 1. Then for half bridge is 2. Then for full bridge is 4. So this is the bridge constant for each type of Winton bridge configuration. This is again the explanation for the compensation bridge where we use the null equation for the Winton bridge. So if we consider R1 and R2 is the strain gauge and mounted onto the same structure, so both strain gauge will give the same resistance change due to the temperature. So R1 will have change of resistance due to the RT and R2 also have change of resistance due to RT. So from this equation, change of resistance will be compensated by each other, make the bridge still balanced. Therefore, Therefore, R2 is considered as a dummy gauge.